Good morning, happy Wednesday. Today is day 111, and for this video and our whole lesson today, we're going to be focusing on the rotation. Again, you should be familiar that the rotation, that's a type of transformation. We're going to spin something around a point, we're going to spin an object or spin a shape around a fixed point. Today, our big goal is going to be seeing what happens to the coordinates for points when we rotate them around the origin. So for your first problem today, part A showed you a graph where we have a green triangle, triangle ABC, and they tell us some transformation turned ABC, the green triangle, into ABC prime, the purple triangle here. Part 1 asked you what kind of transformation took place to explain how you recognize this type of transformation. By now, you and your partner, you and your neighbor already should have worked through these problems, and you should now be on part 3 analyzing my work, so I'm going to go pretty quickly as we explain each part that you hopefully did on your own already. So for part A, what kind of transformation took place here on this graph? We should all see this object spins around. Point A is pointed to the top, now it's pointed to the side. So the transformation that took place here was a rotation. How did we recognize that type of transformation? For me, at least, I can see that the object was spinning around. It's pointing in a new direction. It doesn't look like it flipped across like a reflection. It looked like it spun to the side and spun downward, so that's going to be a rotation. Part 2 asked you to start specifically describing that rotation. I'm going to see that part C and part D, you should have seen both of those answers are wrong right away. Those are distractors because they talk to us about a reflection, and we see that this is not a reflection, this is a rotation, so A and B are out. The two big things we're going to focus on today, do we spin in a clockwise or counterclockwise direction? Most efficiently or most quickly, we spin the green to the purple in this direction, and if you think about a clock, we're kind of pointing at 1 o'clock. Now we're kind of pointing at 4 o'clock. We spun in a clockwise direction. How many degrees did we spin? The key here to understand is that to spin all the way around a graph is 360 degrees. So halfway around is 180, and this is a quarter of the way, or just one quadrant, so we tilted just 90 degrees. We'll talk more about why it's a 90-degree rotation, but the big thing you should see, line A to B first goes straight up and down. Now it goes sideways. If we look at the old AB and the new AB, they would form a 90-degree angle. We spun 90 degrees and we rotated around the origin in a clockwise direction. Hopefully we've already worked through part B as well, you and your neighbor, but as we work through it, part B says, what is the single transformation? We'll go ahead and highlight that. What is the single transformation that proves this orange XYZ triangle is congruent or the same size and same shape as the pink XYZ prime triangle? Our description, when we describe that transformation, should be as precise as possible. What they mean by that, talk about the direction we spin in, talk about the number of degrees we spin. Hopefully you see here the single transformation that could get orange to pink. There it's the opposite side of the graph. It spun halfway around. X used to be pointing up. Now X is pointing down. We spun halfway around. Z used to point to the left. Now it points to the right. So the transformation that took place was, again, a spin, a rotation, this time halfway around the graph. That means a 180-degree rotation. Could be clockwise or counterclockwise. We'll talk more about the reason for that. Either way, if you spin halfway in a counterclockwise or halfway in a clockwise, both 180-degree directions is exactly halfway around, so it could be either direction here for 180 degrees. On your own, without me, you're going to complete part 2 and part 3. You're going to take a look at the coordinates here for the old orange triangle and the new image, the pink one, and then try to figure out what happens to each of our coordinates when we rotate by 180 degrees. Thank you for listening to the end of the video. Ms. Stewart is out today, so if you have any questions, please ask me directly or use Classroom Q.